Somewhere in the open ocean, something no larger than a paperclip drifts across the surface of the sea. It doesn't swim, it doesn't dive, it simply floats, carried slowly by waves and currents, turning gently beneath the sunlight. At first glance, it looks like a fragment of blue glass or a tiny piece of plastic lost at sea. But look closer, because this drifting speck is a predator. Its name is Glaucus atlanticus. Most people know it by another name, the blue dragon. And despite its delicate appearance, this animal survives in one of the most dangerous environments on Earth, the surface of the ocean. From a distance, the open ocean looks empty, just endless water stretching to the horizon. But the thin layer where air meets sea is actually a floating ecosystem, a place scientists call the Newston layer. Life here exists in constant exposure. Birds hunt from the sky, fish strike from below, and the sun burns directly overhead. Creatures living here cannot easily escape. They cannot dive deep. They cannot hide in reefs. They drift, and drifting means danger is always close. Yet somehow the blue dragon thrives here, floating upside down across the open sea, and it does so using one of the strangest survival strategies in the animal kingdom. Because the blue dragon does not just hunt dangerous prey, it steals their weapons. But first, look at the animal itself. The blue dragon barely grows longer than 3 centimeters, yet its body spreads outward into branching arms that look almost like wings. Its upper side is pale silver. From below, it disappears against the bright sunlight filtering through the surface. To predators scanning the water, the blue dragon almost vanishes, a drifting illusion. But camouflage is only the beginning, because the blue dragon hunts something most animals avoid at all costs. Floating nearby, carried by the same ocean currents, is a creature feared even by humans. Long blue tentacles stretch through the water like living wires, each one armed with thousands of microscopic harpoons. Touch them once, and the result is immediate. Venom, pain, sometimes paralysis. This drifting predator is the Portuguese man-o'-war. Despite its jellyfish appearance, it isn't a single animal, it's a colony. Multiple organisms working together as one floating predator. Its gas-filled sail keeps it drifting across the surface. Below it trail tentacles that can stretch more than 30 meters long, every inch packed with venom cells called nematocysts. Each nematocyst is a microscopic harpoon loaded with toxin. When triggered, it fires instantly. Fish avoid them, many animals fear them. But the blue dragon approaches them, slowly, carefully, gripping the tentacles with specialized jaws. Then it begins to feed. Piece by piece, the blue dragon eats the venomous tissue. But what happens next is even stranger. Because the blue dragon does not destroy the venom cells, it keeps them. As the prey is digested, the microscopic harpoons pass through the animal's body without firing. Instead of breaking them down, the blue dragon transports them into special storage sacks inside its branching limbs. There, the stolen weapons remain intact, loaded, ready. Scientists call these storage chambers cenidosacs. They function like biological ammunition magazines. Inside each delicate limb are clusters of venom cells taken directly from the Portuguese man-o'-war. And that changes everything. Because now the tiny drifting sea slug carries one of the most powerful stings in the ocean. If a predator tries to attack it, the blue dragon releases those stolen harpoons, delivering a venomous sting that can sometimes be stronger than the original Portuguese man-o'-war. In other words, the more dangerous its prey is, the more dangerous the blue dragon becomes. But hunting venomous prey is only part of the story, because drifting across the ocean creates a much bigger challenge. Finding another blue dragon. The open ocean is enormous. 2 individuals can drift for months without ever encountering another of their kind. And when they finally do meet, what happens next is something very few animals on Earth can do. Because the blue dragon solved the problem of loneliness in the ocean in a way that seems almost impossible. and the solution reveals just how strange this creature really is. Drifting across the open ocean creates a problem most animals never have to face. Finding another member of your own species. The sea is enormous. Currents carry floating organisms across thousands of kilometers of water. Two blue dragons might drift for months, even years, without ever encountering another one. So when they finally do meet, evolution has already prepared a solution. Every blue dragon is both male and female. Each individual carries both reproductive systems at the same time. In biology, this is called being a hermaphrodite. And in the open ocean, it solves a critical problem. Because when every individual can reproduce with any other individual, every encounter becomes an opportunity. No searching, no waiting, no wasted chances. But even this system has a strange complication, because the blue dragon carries a dangerous cargo inside its own body. Those stolen venom harpoons taken from the Portuguese man-o-war are still active, still loaded with toxin, and during mating, the animals must avoid triggering their own weapons. To prevent that, their bodies are designed to connect side by side. Their delicate limbs extend outward while the central parts of their bodies make contact. It's a careful arrangement. One wrong movement could release hundreds of microscopic stinging cells. Even reproduction requires precision. The blue dragon produces long, delicate strings of eggs, but in the open ocean, there's nowhere to attach them. No rocks, no coral, no seaweed forests, just drifting water. So the blue dragon uses something else, the same creature it hunts, the Portuguese man-o-war. Instead of avoiding the venomous colony, the blue dragon approaches it again, carefully navigating through the waving tentacles, and then it attaches its egg strings directly to the floating animal. In a strange twist, the deadly predator becomes a nursery. The tentacles that scare away most animals now protect the developing eggs. Few predators are willing to approach something armed with so much venom. For the next generation of blue dragons, it's one of the safest places in the open ocean. Eventually, the eggs hatch. Tiny larvae emerge and begin drifting with the currents. At this stage, they are incredibly vulnerable. They cannot defend themselves. They cannot steal venom yet. They are simply plankton, carried wherever the water moves. Many will never survive long enough to grow. Fish feed heavily on plankton drifting at the surface. Ocean currents scatter them across vast distances. Storms toss them through violent waves. Only a small number will reach adulthood. But the few that do begin to develop the strange structures that define their species. Their branching limbs grow outward. Their gas-filled flotation sac forms inside the stomach. Soon they begin drifting upside down across the ocean surface, just like their parents. And eventually, they begin hunting. But life at the ocean's surface is unpredictable. Food does not appear on a schedule. Ocean currents decide everything. One week, colonies of Portuguese man-o-war may be abundant. The next week, there may be none at all. And when prey becomes scarce, survival instincts begin to change, because the blue dragon has another behavior scientists occasionally observe, one that reveals just how harsh life in the open ocean can be. Sometimes, they eat each other. Cannibalism among blue dragons isn't common, but it does happen. When food disappears and energy becomes limited, drifting individuals may encounter others of their own species. And in those moments, the line between predator and prey becomes very thin. The hunter becomes the hunted. Even then, the attack requires caution, because every blue dragon carries the same dangerous cargo, venom cells hidden inside their limbs. But appearances can be dangerous, because the blue dragon does not lose its stolen weapons when it washes ashore. The venom inside its body remains active, even outside the water. Anyone curious enough to touch one can receive a painful reminder of what the creature carries inside. A sting strong enough to cause intense pain, sometimes strong enough to send people to the hospital. And that is what makes the blue dragon so surprising. A creature smaller than your finger, drifting helplessly with the currents, yet armed with the stolen weapons of one of the ocean's most venomous drifters. But even after everything we've learned about this tiny predator, there's still something remarkable about how it survives. Because living at the surface of the ocean requires more than venom, more than camouflage, more than drifting. The blue dragon's entire body is built to solve one final challenge: staying afloat in one of the most unstable environments on Earth. Living at the surface of the ocean may sound peaceful, but for creatures that actually exist there, it is one of the most unstable environments on Earth. Winds change constantly, waves rise and collapse without warning. Currents move across entire oceans, slowly carrying anything that floats within them. For the blue dragon, there's no solid ground, no reef to hide inside, no burrow to retreat into, only water stretching endlessly in every direction. And surviving here requires a body designed specifically for drifting. Those strange branching limbs that give Glaucus atlanticus its dragon-like appearance are not just decorative structures, they are part of a precise survival design. Each branch increases the animal's surface area, and more surface area means more resistance against sinking. In simple terms, the blue dragon's body acts almost like a parachute in water. The wide feather-like limbs slow its descent and help it remain suspended at the surface. But buoyancy depends on something hidden inside the animal as well. Inside its stomach is a small gas-filled sac. That trapped gas acts like a flotation chamber, making the animal slightly lighter than the surrounding water. Together, the gas sac and the spreading limbs keep the blue dragon balanced at the very top of the ocean, upside down, drifting slowly between air and sea. And once it reaches that thin boundary layer, the currents take control. From space, ocean currents look like enormous rivers flowing across the planet. Some travel thousands of kilometers before they weaken or change direction. Anything floating on the surface becomes part of that movement. Blue dragons cannot control where they go. They simply ride those massive rivers of water. An individual born near the coast of Africa might eventually drift toward the Caribbean. Others travel across the Indian Ocean. Some appear near Australia, Portugal, or the Gulf of Mexico. For such a small creature, the scale of that journey is extraordinary. Entire lifetimes spent drifting across oceans. Yet despite all that movement, the blue dragon remains almost invisible because its strange coloration continues to hide it even in open water. The deep blue underside blends perfectly with the darker ocean below. The pale silver upper side reflects the bright sunlight above. Predators searching the surface often miss it completely, a drifting fragment of color that disappears against the water. But the blue dragon is not alone in this strange floating world. The Newston layer contains an entire community of animals that survive the same way. Portuguese man-o'-war drift with wind-filled sails. Colonies of Velella skim across the surface like tiny blue boats. Sea snails known as genthina create floating rafts made from bubbles of mucus and air. Each species uses a different strategy to survive: venom, sails, bubble rafts, or drifting camouflage. Together they form a fragile ecosystem balanced on the skin of the ocean. And within that floating world, the blue dragon occupies a very unusual role. It is both predator and recycler. By feeding on venomous drifters like the Portuguese man-o'-war, it helps control their numbers. Without predators, colonies of these stinging organisms could spread across vast areas of ocean. Instead, animals like Glaucus atlanticus help maintain balance in this drifting ecosystem. But what makes the blue dragon truly remarkable is the way it solves problems. It did not evolve its own venom. It did not grow powerful, stinging cells like jellyfish. Instead, it borrowed them. Evolution found a shortcut. Rather than building a weapon from scratch, the blue dragon simply recycled one from its prey. And that strategy created something extraordinary: a tiny sea slug armed with the weapons of a far more dangerous creature. But despite all its unusual abilities, the blue dragon remains one of the least understood animals in the ocean. Scientists rarely see them in their natural environment. Their drifting lifestyle makes them incredibly difficult to track. Most discoveries happen only after storms push them onto beaches, which means much of their story is still hidden out there, somewhere across the open sea, drifting quietly with the currents. And yet, every so often, the ocean reveals them. After strong winds and shifting tides, waves sometimes leave behind a strange sight along the shoreline. Tiny blue dragons scattered across the sand, proof that even the surface of the ocean still hides creatures almost impossible to imagine, animals that challenge what we think life should look like. Some survive in the darkness of the deep sea, some cross entire oceans guided only by currents, and some, like the blue dragon, spend their entire lives floating at the very top of the water, small enough to overlook, strange enough to seem unreal, yet perfectly designed for a world balanced between air and sea. Because the most extraordinary creatures in nature are not always the largest or the strongest. Sometimes they are the ones drifting silently where almost no one thinks to look, right at the surface of the ocean.